Okay, so implicit differentiation then. So this is whenever we're differentiating expressions that involve x and y, and they're expressions that we can't write in the form y equals some function of x. So find dy by dx in terms of x and y, where x cubed plus x plus y cubed plus 3y equals 6. So there's no way we could write this as y equals something. Okay, and this is fairly straightforward. We just differentiate everything as we go along, and if there's a y involved in it, you follow it with dy by dx. So we differentiate our x here, so x cubed, differentiate it, we get 3x squared. Differentiate x, we get 1. Differentiate y, we get 3y squared. We're differentiating y's, so multiply it by dy by dx. Differentiating 3y, we get 3. It's a y, so times by dy by dx. Differentiate 6, we get 0. So keeping our dy by dx's on one side, and we'll bring everything else across to the other side. Factorize. And then divide across by your bracket. Okay, our next one, find the value of dy by dx at the point 1, 1, where 4x y squared plus 6x squared y equals 10. Now the first thing I'm going to do, because you can see we've got a product here and we've a quotient here, I'm going to rewrite that slightly. To bring the y up to what be y to the power minus 1, which means we've got two product rules that we're going to have to use here. It's a wee bit easier than to do the quotient rule. So product rule then on our first term. So it's 4x times differentiate y. We get 2y, it's a y, so multiply it by dy by dx, plus y squared times differentiate 4x, and we get 4, plus 6x squared, so these are our two products here, times differentiate y to the power minus 1, we get minus y to the minus 2, it's a y, so times by dy by dx, plus y to the minus 1 times differentiate our 6x squared, we get 12x, and differentiate 10, we get 0. Now I'm going to tidy it up slightly. But I'm not going to tidy it up too much, because in this question here we're given our values of x and y, and we have to find a numeric value for dy by dx. It's not like the first one where we had to find an expression for dy by dx. So x is 1 and y is 1, so put that into our equation here. We get 8 dy by dx plus 4 minus 6 dy by dx plus 12 equals 0. So 8 dy by dx take away 6 dy by dx is 2 dy by dx. Your 4 and your 12 are 16, and I'm going to bring that across and make it minus 16. So dy by dx at that point is minus 8. Okay, our third one then. Find dy by dx at 1, 1, where a to the 2x ln y equals x plus y minus 2. So this has got lots in it. It's got the product rule here, it's got exponential and log that we'll have to differentiate, and then just normal differentiation. So we've got a product here, So it's e to the 2x times differentiate ln y, we get 1 over y, and it's y, so times by dy by dx, plus ln y times differentiate e to the 2x, we get e to the 2x times 2. So that's the left hand side, and that equals differentiate x, then we get 1. Differentiate y, we get 1. Remember it's y, so times by dy by dx. Differentiate minus 2, we get 0. So again, I'm not going to tidy it up too much. Okay, because again we're given a point that we have to find the value of dy by dx at. So x is 1 and y is 1. So putting that in, we get e squared over 1, which is just e squared dy by dx. Now if we have ln 1 here, that's 0, so this whole part will go to 0. Goes 1 plus dy by dx. So bring all the dy by dx's to one side. Factorize. And then divide across. To get 1 over e squared minus 1. Now you could find out the value of that, but this would be, especially if the question asked for exact values, you would leave it then in this format.